So first of all, what is a ZK VM? Right, just overall concept. I believe most people here know because it's a ZK hacker house. But the idea is that on Ethereum today, the nodes, whenever you're going to validate, you have to recompute all the transactions. So whenever there's a transaction and another node wants to verify it, or you want to spread out, you have to recompute. With ZK, you can just compute once and verify that, and then it makes things a lot more efficient. And why ZK EVMs and not only ZK VMs? Because today there is some differences between how ZK computation works and how normal computation works. And the EVM is, it was created to compute normal computations. And sometimes some things that are efficient in normal computation is not efficient on ZK. So basically, some computation that is efficient on bits, it's not efficient in polynomials. But then why do we do ZK VM? It's because of network effect, because people already know about EVMs. There are a lot of toolings about EVM. A lot of developers know Solidity. So there's already a strong community around. And at the same time, ZK can bring scaling. So that's why I believe ZK EVMs are so powerful. The price to pay is performance. Definitely, if you had a full ZK VM, not EVM machine, you would be a lot more efficient. But then the trade-off is that people would not have to learn new languages, new tools, and all that. So how does Kakarot ZK VM works? Basically, the user set a transaction. Right now we are as a smart contract. And then basically you send the call data to the Kakarot EVM, ZK EVM, and then it will do the execution layer. And this is just a little flow of how it's done and how is it structured behind the scenes. And then basically it computes and then have state transitions on right now on the StarkNet blockchain, and then it will be validated on L1. This is one of the reasons why Kakarot, we started in October, and this is one of the reasons why Kakarot have been able to build a lot of opcode super fast. If you see most of the ZK VMs, they've been working for 2 years, 3 years. And right now we have implemented all the opcodes. We only have 2 precompiles remaining, which should be done soon. And the idea is because basically we don't do the ZK part. We don't, the Kakarot team does not do ZK. Today, all the ZK teams, they have to do like very deep ZK. We just use Cairo, which is already a working ZK proving system framework, and we build on top of that. And the reason why Cairo is so powerful is because it's built on top of Starks, and the difference between Starks and Snarks, one of the main differences is that on Starks or with Cairo, you have a general prover or verifier, I mean. So you can verify any code with the same verifier. While in Snarks, you have to have one verifier for each circuit, and that's very painful. For example, you have one circuit for one opcode, one circuit for another. You have to verify and link the verification, and in the end, make one verification. While in Cairo, is just compute everything, verify all at once. And just a little bit of story. It was started as a community project, and it was done by it was initialized actually by the Starkware exploration team. I was just one of the first contributing members, and right now it grew a lot, and now we are becoming we're incorporating, and we're planning on becoming a company. This is just a little joke. So Abdel is who we started, and then in the beginning, all our codes, all our contracts started with Abdel. Now it's not like that because of security reasons, but we just made that, okay, now every contract, every address here in Kakarot ZK starts with Abdel. This was a hackathon joke. We started in, yeah. And now we are a big community of contributors. We have more than 30 contributors, a lot of support from Lambda class, Avnu, Matchbox, Starkware, Theodo, and Fuzzing Labs. So we have a very, very strong team of contributors, which I think it's amazing to see so much work. And you can even see Richie here. And yeah, this is just a technical overview around how the the EOA works on Kakarot because we have account abstraction on StarkNet. We now will have on Ethereum, but like, so yeah, just some technical discussion. And what next? So we came all this way. We developed in Cairo 1.0. We are now discussing if Kakarot can become a L3 or also can stay in L2 as a smart contract and allow any developer to deploy a Solidity contract on StarkNet and even interact with Cairo contracts from your contract. So it's basically we will have two languages of smart contracts in one blockchain interacting with each other normally. Cairo contracts can call Solidity contracts, Solidity contracts can call Cairo contracts. Of course, pure Cairo contracts will be more efficient than Solidity contracts, but for those who are just coming for the first time and wants to deploy and have some applications, and efficiency is not such a big deal, it's good. So yeah, we are now planning on having 1,000 Solidity smart contracts on our environment. Right now, what you can do is, this was developed our CTO this week. You can now have a local DevNet. You can deploy a DevNet, connect your MetaMask, and even send some transaction, and then start playing around with Kakarots with MetaMask. And the interesting thing is that we're using MetaMask, but then when you go see your transactions, you have to see on the StarkNet, StarkScan, and the StarkNet tool. So yeah, so this was the presentation about Kakarot zkVM, which is where I'm currently working at. And if you have any question and if you want to follow us, here's the Twitter link.
One more question. Is the ZK circuit rendered in the bytecode level?
Sorry?
Is the circuit rendered by the bytecode or by the
ZK circuits?
Yeah.
So right now we have implemented all the opcodes in Cairo, which compiles it into ZK circuits. So we have not implemented the circuits ourselves. We are using a ZK language that automatically compiles to circuits.
Okay, so it's in the bytecode level.
Yes, we have an EVM. To implement an EVM, you have to implement each opcode, and basically how it works right now, you have to send all that bytecode call data to the Kakarot EVM, and then that's computed on.
Yeah, so it's still the KVM, right?
Scalability.
It is still the KVM.
Yes.
It's a virtual machine.
Yes.
Okay.
Yes.
The contributor list, I saw a lot of similar NFTs. Does the project have an NFT collection?
No, but what happened is that started with Abdel. It's from the Everai community, and then what happened is that me and Elias and Clement, Elias is CEO and Clement is the CTO, and Abdel just gave us, oh hey, like here's one NFTs one I really like, and I said like, hey, nice, thank you. And then I really liked it, started using on GitHub. Elias started first, then me and Clement we joined, and then after 3 weeks there were 10 people using. Now I think it became so big that now there's like a proper partnership between Everai and StarkNet. Like now, like the partnership is full on. Like a lot of developers are using it, and it just started with like just few people using it, and then now a lot of people are using it.
Let's go.
How long will it take to verify all the transactions of maybe one block?
The transactions, it's similar to a StarkNet transaction, a few seconds, one transaction.
Per transaction.
Yeah, right now we don't have our own block mechanisms because we are right now using the StarkNet sequencer, but we are planning on, this is being discussed, so this is not 100%, but let's say we are L3, I think we'll be very efficient because we will be compiling all the transactions into one StarkNet transaction, which is a lot cheaper than already done Ethereum transaction, and then later be verified on Ethereum.
And the common reference string might be very long, right? In this case,
Common.
the common reference string.
What is that?
I think it's
The proving time?
the proving key. Yes.
We don't need to handle that because, like I said, in Cairo, like you don't need to handle proving keys in Cairo because you have only one verifier for every code. So basically, you just send the code for the sequencer, and he will verify, he will generate the proof, and like you don't need to handle that. And it's actually not so big. There's a lot of applications already running Cairo, for example, DYDX, Immutable X, and they are doing like hundreds of transactions per minute or second. I don't know the exact number, but like they're doing a lot.
Fast.
Yeah, they're doing like a lot of transactions.
Okay.
So can I understand category as a compiler?
We have, so it's not, we didn't build a compiler itself. We're using Cairo compiler. What we built, we could say it's compiling
Because I mean, there are some projects.
bytecode to Cairo. Basically, we are not compiling because we are executing bytecode in Cairo. So for example, if you can build an EVM with Python.
Yeah.
So the Python is not actually compiling, it's just executing. So we are executing in Solidity. And one of the things that can happen also is that, for example, you can use Cairo outside blockchains. So right now, because we have Kakarot, now actually every Solidity code could be provable as well, even outside. Like you just need to execute the Solidity code on Kakarot, and then you will have you can prove that in any Stark or Cairo verifier.
Gotcha, because I mean, there are some projects building a compiler to run Solidity application on Cairo, right? So
There is a transpiler warp.
transpiler,
Yes. So basically, what it does, you put a Solidity contract, and then it will give you a Cairo contract. But if you have seen the Cairo contract, it's very hard to maintain. And they are just literally like translating, like I translate Portuguese to English. They're translating Solidity to Cairo, and that's what we're doing. And in Kakarot, it's a little bit different. We're executing the contract itself. And even we allow like contracts to interact with Cairo contracts. It's not that just generating a Cairo contract. So it's a bit different.
gotcha. So what would be the biggest advantage for Kakarot compared to transpiler?
Because we can execute Solidity codes. The transpiler, it just like, for example, if I receive a call data, I can execute in StarkNet. While the transpiler, let's say I transpiled a Uniswap to Cairo code. You cannot send Solidity call data to that contract. You would have to send StarkNet call data to that contract. In our case, we have the Uniswap, and then you can just send Solidity call data or EVM call. It's EVM call data. EVM call data to that contract. So, and what that allows is that it allows us to integrate to all the toolings that already exist. So your contract that was transpiled will not be able to access all the toolings that Hardhat, Foundry, or even like just connect on MetaMask and have all the transactions. In our case, we can.
Okay, thank you.
Okay, you mentioned L3 at one point. Is that how you can write a Solidity program that compiles with Kakarot and then it's settled on Starkware?
StarkNet.
Yeah, StarkNet.
So there are many ways to do an L3. Maybe I'll disclose not this time, but one of the ways is to have a ZK rollup on top of a ZK rollup. And basically what it does then, the L3 would be L2 proves, like verifies all the L3 state transition. And this verification is verified on L1. So you're like, you're inheriting security from L1. Of course, the finality time will be higher than just a layer 2 ZK rollup, but like you have much more transactions, lower transaction fee, much more TPS, and at the same time having Ethereum L1 security.
Okay, and then L1 in this case is StarkNet.
No, L1 is Ethereum because StarkNet is an ZK roll up on Ethereum. So StarkNet is already inheriting Ethereum security. I think that that's the way to go. Like Ethereum is the most secure and is the safest blockchain we have today.
For sure.
And if you can scale on top of that while maintaining the security, I think that's at least, I think there's no better solution as of now.
Got it.